So in the last video for section 3.2, I said this video was just going to be drill practice, but I thought, there might be some, we might go slower first. And so this is the second part of section 3.2, and we're going to be using the product and quotient rule. Oops, product, quotient rule. Okay, so for example, let's just try a few. Oh, by the way, maybe we should write it down first over on the side here, just to have it. The product rule is f prime g plus fg prime. The quotient rule is f prime g minus fg prime divided by g squared. Good. Now, example 1. Let g of x be equal to 1 minus 2x divided by 3x plus 1. Find g prime. Okay, I'm going to pause there just for a second and let you think about it. Are you ready? Now, like we were saying last time, you could write a little table of functions if you want, but since they're just two polynomials, it might be something we can just work out live, for example. So what is the derivative of the top? That's the way we always start. Derivative of the top is the way we always start. Derivative of the top. Derivative of the top. Okay, derivative of the top is minus 2 times the bottom. Minus, that's an important one there. People tend to forget the minus sign. The top function times the derivative of the bottom divided by the bottom squared. Good. Now, just for practice, we sometimes want to simplify this. So in this case, can we simplify that? Minus 6 minus 2. We haven't done a lot of these. Minus, that's going to be 3 minus 6x. And by the way, use parentheses. That's always a good idea. And in this case, things simplify quite a bit, right? Minus 6x plus 6x. The 6x's will cancel. So we'll have minus 2 minus 3 is minus 5 divided by 3x plus 1 squared. Good. All right. Example 2. Use the product rule, or maybe we can use the quotient rule to find a formula, to find what we'll call the reciprocal rule. Reciprocal rule. So suppose that we just have 1 divided by f of x, and we want to take the derivative. What would that look like? Let's call this g prime. Okay, so then let's see, derivative of g prime will be derivative of the top is 0, so it doesn't matter what else comes after, minus the top function times the derivative of the bottom, right, divided by the bottom squared. Good. And so notice that if you're differentiating, let's make a conclusion here. The derivative of 1 over f of x is minus f prime of x divided by f of x squared. Okay, and so this is what's called the reciprocal rule, and sometimes it's useful to use this directly without using the quotient rule, but we don't need to memorize this as a separate rule if you don't want to. Okay. All right. Let's try some more. Example 3. Differentiate x times f of x. So one way to write it would just be to say f of x prime is equal to, and now the derivative of the first is 1 times f of x plus now, right, because we're doing the product rule, the first function times the derivative of the second. Good. So you could say that's f of x plus x times f prime of x. Good. Now, example 4. Suppose that I know that f of 1 is minus 1, f prime of 1 is 2, g of 1 is equal to 2, and g prime of 1 is equal to 3. Find the derivative of fg at 1 and f over g prime at 1. So this says differentiate before you plug in 1, right? So if we take a look at that, looks like, geez, my wrist is right at you there. That's going to be f prime of 1 times g of 1 plus f of 1 times g prime of 1, right? So we just plug in our numbers at that point. That's going to be 2 times 2 plus minus 1 times 3. Good. So let's see, 4 minus 3 is equal to 1. Now f prime, if we do the quotient, that's going to be f prime of 1 g of 1 minus f of 1 g prime of 1 all divided by g squared of 1. And so numerically, right, that's going to be f prime of 1 was 2 times g of 1 was 2 minus f of 1 was negative 1. G prime of 1 is 3 divided by g of 1 squared. Good. Oops, I'm running out of room there. So that's going to be 4 plus 3 is 7 divided by 2 squared is 4. Good. So sometimes we're given the functions only as numbers, right, instead of as formulas. And so we can still do the same thing that we were doing before. All right. So I think I'm going to stop there and let you guys try out the homework problems and also the drill problems that I said was the next video. So you might work through some of the homework before you go to the drill problems. The drill problems are really there just to emphasize kind of the memorization of the formulas. It's just to help you with those. All right, I'll talk to you later.